Okay, last little bit on 28.3. So we're looking at making amides, and we make amides using amines. Now, what I'm going to do is I'm going to put a little link here. So you were first introduced to amines reacting with acid chlorides in 26.5. So I'm going to put C26.5 acylation, okay? Because this is what this is, all right? I'm only bringing it back up here again because we're in the amine topic. So let's have a look here. So let's draw an acid chloride. So here we've got an acid chloride, and let's draw an amine. I'm going to pick a primary amine. This would still work with other types of amines as well. So when you're greeted with a couple of molecules here and you think, right, well, I don't really remember this particular topic, where do I start? Okay, well, let's first of all, let's spot where you might have a lone pair. There we go. And let's look at the other molecule. Let's spot where you might have a dipole. Well, chlorine and oxygen are more electronegative than carbon, so it's going to pull the electrons towards the oxygen and towards the chlorine. And that's going to give you a clue for where to start your mechanism. So we've got a source of negative charge here, which has attracted that positive carbon. Remember, carbon can only bond 4 times, therefore you're going to break one of these bonds here. So this is our nucleophilic attack bit. You'll have seen these mechanisms before in topic 26. Sometimes in your exam, you wouldn't necessarily get a question on a particular topic. It would be a question where it brings a lot of different topics, and this is why we're looking at this now. So we've got your nucleophilic attack bit, and then we have our elimination bit. So chlorine is a very good, what we call, leaving group. So the chlorine will leave, and we turn that single bond back into a double bond here, like that. And this isn't stable, so we take off that hydrogen there to make HCl, and our final product would look like this. Plus HCl, of course. Okay, so let's have a look, see what we've done in this mechanism here. So the amine adds on to the acid chloride. So the amine adds on to the acid chloride. And then HCl is eliminated. So remember, we'll call this an addition-elimination reaction, or completely nucleophilic addition-elimination reaction. So I think now might be a useful time just to flick back through your notes and to look over 26.5, these acylation mechanisms. So here's an example of that. And what do we have here? It's not an amine, this is an amide. So an amide produced. Remember, an amide has got a C-double bond in as well. Okay. Right. Okay. So so this is how you'd make an amide, and you'd use amides to make things like a polymer, which we'll do in a different topic. And examples of those polymers from amides are nylon. So nylon is made from an amide. Okay. So that's how you make an amide from an amine. And we need to know a use of amines as well. So amines are used in the manufacture of materials such as nylon here, for example. So one use of an amine could be is used to make polymers called nylon. Don't say we use them as polymers because they're not polymers. They're small molecules, but use them to make polymers such as nylons. We'll show you how to make nylon in a different topic. And not amines, but what's derived from amines, we know we can get quaternary ammonium compounds. And we need to know the uses of those. So let's just draw a quaternary ammonium compound. So quaternary means 4 R groups. So let's draw 4 R groups coming off this nitrogen here. Because there's 4 bonds off the nitrogen, it must have a positive charge. I'm going to make this R group really, really long. So I'm going to put a long wiggly tail there. What we've got here is a CH3, CH2, 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 CH2. Okay, so that's a long R group basically. All right, so this is a long hydrocarbon chain here. So for a long hydrocarbon chain, this is your non-polar end. And we have a positively charged bit on the end there, okay? And that is our polar bit because it's charged. And what we can use these for is we can use these in things like conditioners. So, for example, hair conditioner, or fabric conditioners. So what happens is the negative charges on your hair. So if you've got static hair, you have these negative charges on your hair, and these positive charges here on your cations attract to the wet surface in the form of a coating that prevents a build-up of static electricity on your hair because these are positively charged, and it keeps the surface of the fabric smooth as well in fabric softeners or fabric conditioners, and obviously stops your hair sticking up in hair conditioners as well. That's why if you wash your hair and you don't use hair conditioner, it can be like kind of sticky uppy. And the reason why it's sticky uppy is because your hair has got all these negative charges on it, and those negative charges are going to repel. Because those negative charges repel, your hair sticks up. But if we put some hair conditioner on, those positive charges, they neutralise those negative charges, and your hair kind of sticks down normally. Okay, so that's how fabric conditioner and hair conditioners work. So a use for quaternary ammonium compounds is hair conditioner and fabric conditioner.